Good evening, everyone. Welcome back to my YouTube channel. I am Ganeshan, Assistant Professor, Department of Computer Science Engineering, SNS College of Technology, Coimbatore. So today we are going to learn floating point arithmetic. In the last two sessions, we studied the basic types of number systems and their conversions and binary addition and binary subtractions. There also studied binary multiplication and division also. In this session, I will show you some other type of number system, floating point number systems. What is mean by floating point? Suppose we want to go to buy a product at 10 rupees means it's a decimal number, exact real number, integer. Suppose sometimes we bought the product at the price of 10 rupees 50 paise. How to mention this? 10.50. Here that 50 paise is returned after 10. Then we place dot between 10 then 50. Okay, so any real number or integer with fraction or a decimal point, after decimal point some number is placed, means is a floating point number. So we will go inside. Here one example is given. So right side 1, 2, 3, 4, 5 is there. 12,345 is the real number or integer. There is no fractional part. The right side, the same number is returned 1.2345. 1.2345 is a fraction. After that we place it exponent into 10 power 4. So in this example, we know that a floating point number has 3 parts. One is significant part after dot, then exponent part, the power, that means a 10 power 4 or 2 power 4. That suppose sometimes we return in a binary form, it's 2 power. That means the 10 is a base here, decimal number, so the base is 10. So IEEE 754 is a standard, worldwide accepted standard for representing floating point numbers. So any floating point number we are using in computer systems, this must be represented by IEEE 754 standard. And what is IEEE 754 standard? So it's a worldwide accepted system for representing floating point numbers. Here I have given some example for floating point numbers, 3.14 and 2.71. We know that 3.14 is 22 divided by 7, the value of pi in mathematics. Then we know that binary number systems has only 2 bits, zeros and ones. So any binary floating number is returned only after dot, zeros and ones. So there are two types of 754 form. One is 32-bit floating point binary number, another one is 64-bit floating point binary number. What is mean by 32-bit, 64-bit? So total number of bits is 32, means it's called as 32-bit floating point number. We represent a floating point number in 64 bits is called as 64-bit floating point number. How to represent floating point number? Here exponent part, sign part, exponent part, then significant part after one that. Any floating point number is written with three parts. The first part is sign bit. Suppose we are writing a positive floating point number, means the sign bit is 0. Suppose sometimes we are written any negative floating point number, example minus 2.35. So sign bit is 1, minus 1. So here any positive floating point number we give 0 as a sign bit. Any negative number we give 1. So the second important part in the floating point representation is exponent part, the power. That means decimal number is the base of 10, binary number is the base of 2. Here we are using only binary number, so the exponent part as a base of 2. Then fractional part, that means it's just numbers after the dot. Okay, so three significant parts are the sign bit, exponent bit, fraction bit. So 754 floating point numbers are in two types. One is 754 32-bit single binary digits, then double precision number. The single precision numbers uses only 32 bits. The double precision numbers are using 64 bits. Here the examples are given. The double precision float number, so the total number of bits are 64. One more example is given at the bottom. The decimal number 74.5 is written in double precision number. Here we learned how to convert the floating point decimal number into binary floating point number. It's very simple. For example, one example is given here, 0.8125. So we consider only floating point, means after dot only we consider. So we return what numbers are there in the fractional part. Here 0.8125 is there in the fractional part. Okay, we return 0.8125. We multiply that digits with 2. We get 1.625. So we have taken 1 as the first bit after dot. Then again the fractional part 0.625 is multiplied with the 2. We get 1.25. Then 1 is taken, then 0.25 is again multiplied with the 2, we get 0.5. Then 0.5 is again multiplied with the 2, we will get 1.0. So now we reached the end. That means we after fractional part we get 0. There is no further divisions. Okay. So we return the binary floating point number look like 0.1101. Understood? Again, I will explain. The numbers after floating point multiplied with the 2. Suppose we will get 1 point something, we will took 1 as a first number. Then remaining fractional part again multiplied by 2 repeatedly to reach 0. So the fractional part is written as 0.1101. Here we convert 0.1101 into normalized form. What is meant by normalized form? So rightmost bit we will consider 1. So 1.101 is a normalized form of floating point numbers. So single precision floating point number has 32 bits. Double precision floating point numbers are 64 bits. So some homework has given here. So you will convert the decimal number 12.75 into IEEE 754 standard in a single precision floating point number. You will try to convert it into double precision also. And second sum, add 111.11 and 101.01. This is not a decimal number. Think that this is a binary number. Understood? Here some reference material also given. If you need, you find the answer there. So thank you so much for you all. That's all in the session. See you again in the next presentation. Bye. Take care. Good night.